Hello everyone, this is Louis, and as you can see I have REVEN open on the Tokio chat scenario. Today I will walk you through this trace and use it to demonstrate the power of backward taint analysis between processes in REVEN. I will also show you how you can use the REVEN Python API to filter taint results. Alright, let's go. So, as usual, you can click in the timeline widget here to move forward in time, forward or backward, and it will update the other widgets here. So in the middle you have the instruction widget, which contains a list of all the instructions that are executed during the trace. And in the VM, while it was recorded, on the right you have the CPU widget, which contains the state of the various registers. And on the left you have the backtrace widget, which provides you with a backtrace. You can also note here a status bar here containing various useful information such as the current instruction, the current ring, and the current process that we're in at this point. Okay, but what exactly happens in this Tokio chat scenario? To find out, I can easily open the frame buffer here. Yep. That indicates what appeared on screen while I was recording in the VM. So what we can see here is that we have three command.exe opened. The first one is running a chat client with a nickname Alice. The second one is running another chat client with a nickname Bob. And the third one is running the server, which is connecting Alice and Bob locally. As you can see, Bob is about to send the hello message, and sure enough, if I move forward, Alice is receiving this Bob hello message from Bob. So what I propose we do today is we are going to track this Bob hello message that is printed in Alice's console here, and we will see how it goes backward to the server and to Bob, who originally sent this message. So the first step is to find this Bob hello string in the trace, and to do this, fortunately, I can use the strings widget here, which contains a list of all memory accesses in the trace that are accessing memory locations looking like human readable strings, at least for some definition of human readable, I guess. Okay, so I can filter by my Bob hello here, enter, and I have a list of memory locations that were accessed at some point and containing Bob hello. Since I want the one that is printed in Alice's console, this is certainly the last one. So I'm assuming it is the last one in the list, and I'm picking that one, and when I do, I get a list of accesses here to this string here, and I can pick, for instance, one access, and I will be transported here. And from there, I can open a memory view of a string that is manipulated here. So if I open this memory view here, I can see I have the hello, the Bob hello string in memory, and I can select 1 byte. Select 1 byte and copy it in order to taint it. So I will start the taint analysis widget, and I will taint from this current instruction to the beginning of a trace, and I will taint this memory location to track it backward in time. There we go. Alright, so we've got the results here. The results here are a list of the changes to the state of a taint that indicates me what became tainted at some point and what lost the taint at some other point. And this allows me to track the Bob hello string through its various operations in the trace. And if I iterate through the result, I can see that I start in the console host process, which is probably Alice's console host, where the message is printed after it has been received. And if I go backward, so yeah, the results are displayed anti-chronologically, since this is a backward taint. So if I go back a bit, I can see that I'm still in the console host, and then I get inside of the chat client, which is probably Alice's chat client that received the message. And if I move forward a little bit more, I'm in the chat server that forwarded the message. And if I keep moving, I will eventually end up in the other chat client, so Bob's chat client that sent this message. And if I go to the end of the trace, to the beginning, I will end up at the console host that sent the message, where the message was Bob's console host, where the message was originally entered. Okay, so this is nice. You can see all the buffers that the taint went through, but this is a lot of information. And if I'm just interested in seeing the various processes that the taint went through, I cannot do this with the GUI, unfortunately. So I will have to use the API. And this is where the API enters the stage. And I will switch to my Jupyter Notebook. So for those who wouldn't know, a Jupyter Notebook is a web interface to display and execute Python code, among other things. And I can use it, for instance, to add some code cell. And if I say print hello REVEN, and I execute it, I get the output here if there is an output. Alright, so I'm going to use this Jupyter Notebook interface to demonstrate the REVEN 2 API. Alright, to use the API, we'll start with importing REVEN 2. Alright, then I have to connect to the project manager here, which is at this URL. And the project manager is what manages our project, the scenarios that have been created inside of REVEN, and for instance, the Tokio chat scenario. So once I have my connection to the project manager, I will ask to connect to the Tokio chat scenario specifically. This will give me a connection object that I can use to retrieve a server object and a trace object, and I can use this trace object to perform various queries, like getting the number of instructions in the trace. Alright, so I'm connected, and here is the number of instructions in the trace. From there are basic operations I can do, like printing instructions. So here I'm printing the first instruction in the trace, and then some instruction, and then the last instruction, and I see the result here. From there I can access the CPU context, right before and right after executing an instruction. So for instance, if I access the CPU context before executing the first instruction and after executing it, since it's a push, I can look at the value in RSP and it will change, and I can display it. So okay, changed. I can also, for instance, read the CS register to know if I'm in kernel learned or user learned. I can access the process information, current process information, like in the GUI's status bar, and the current process that we're executing. And I can also read memory at some instruction here. I'm reading this at this address, 12 bytes, and here's the results. Our hello string again. Alright, what I like to do here is perform a simple taint, the same taint as I did in the GUI. So if you remember, this is a picture of a frame buffer here, and I have this Bob hello message that I received in console, in Alice's console, and I want to taint it backward in time to see how it goes back, so the server and the clients and Bob's clients. So I will do exactly the same as in the GUI. I will start by filtering on strings here. I'm filtering on Bob hello strings, and I want the last one, which is indexed by -1. And then I will get its memory span, its address, and its size, and I will say I want to taint this. So I want to taint this. I want to taint this from the first access to this string to the very first instruction in the trace, and I want to taint this in backward. So this is exactly the same thing as what we did in the GUI. The only difference here is that I'm tainting the full string rather than a single character like I was doing in the GUI. So if I start this taint, this spawns a taint object, which is a background taint process, which is generating our results, and I can then query our results here. So this will query all the changes to the taint states like we had in the GUI, but what I can do that I couldn't in the GUI is further filter these results. So this is what I'm going here. I'm checking the current process on each change, and I'm collecting a result only if the process changed. I'm collecting the results inside of a HTML table, since Jupyter allows me to render HTML, and then at the end I'm displaying all the table lines I've collected. Okay, so here's the results, and I can find my processes very easily. So I'm starting in Alice's console host again, which printed the message Bob hello. Then I have Alice's chat client that received the message, then the chat server that forwarded the message, then Bob's chat client that sent the message. And here I can see that the taint is in two different buffers, in Bob and in hello. And this is because if we look at the frame buffer, we can see that Bob sent his nickname and the message separately. So these are two different buffers that are tainted here. And if we can even go back to the console host where Bob originally entered his message, and we can see that every character is tainted individually. And this is because these are actually UTF-16 characters and not UTF-8, but they are pairs of characters with one ASCII character and one null characters. And since the null characters aren't used in the taint, they're not tainted. So this is why we can see only one character out of two is tainted here. All right, so what we've seen here is very simple use of the taint API, both in the GUI and both in the REVEN Python API, just to follow inter-process taint in a simple communication between server and client scenario. And I hope you like this video. If you'd like to know more about REVEN, you can go to our to tetran.com, our website, which features tutorials and vulnerability analysis in our blog, as well as demos. If you'd like to test the GUI yourself, you can start the demo from here. Thank you for watching.